So welcome to the third video from Chapter 2, Section 6. We're going to try to put all this stuff together, figure out how it's useful, and actually be able to get a little sketch of a rational function. So we've talked about end behavior. We've talked a little bit about vertical asymptotes. We'll probably add a couple new things for that. We've definitely talked about x and y intercepts. And if we can find all that stuff and maybe figure out a few additional points as needed, we should be able to come up with a little sketch of the rational function. So up on top here, example 3, we have a rational function. And if you think this through, we've also factored some things apart. So I could take a 2 out of both of these parts in the numerator and get x squared minus 9, which would split into x plus 3 and x minus 3, so we took that apart. This right here, if we went through, we took a little time in our first unit to figure out how to factor that apart. You get 2x minus 5 and x minus 3. We can definitely go over that in class if you want to, but most of the rational functions that the book gives us, we will be able to break apart like that. And so that's going to give us a lot of info here. So first, if we talk about the end behavior, remember in our first video we talked about taking the leading degrees in top and bottom. So 2x squared and 2x squared, if we just find that ratio, we get 1. And so that's going to tell us our horizontal asymptotes. On either end, our graph is going to level off at 1. If we were to think about any vertical asymptotes, in general that comes from the denominator. And if we see the same chunk on top and bottom with the x minus 3 part, that means we have a hole. And so when we plug in a 3, we're going to have issues. There's a hole at 3, a vertical asymptote at 5 halves, because that's going to make the 2x minus 5 equals 0. If I went through and I solved that, I would get x equals 5 halves in the end, or 2.5. Okay? Now to find the x and the y intercepts, that's what we just went over in our last video. To find the x intercepts, I'm going to make the numerator equal 0 and work backwards from there. So really I could say it probably would be easier to take the second numerator, the x plus 3, 2 times x plus 3 and x minus 3. So we're going to have x intercepts at negative 3, comma 0, and at 3, comma 0. And then the y-intercept, we can just take the constants in the top and the bottom. So that would be at 0, comma negative 18 over 15. So all that comes from the video that we just watched. And then parts A kind of came from the first video for this lesson, and then part B, hopefully you've covered that before, or we'll talk about it in class at some point. So we have a lot of info now that we can put on our graph, and then we might need to think of a few other points. So if we just kind of zoom in on our graph here and we start labeling a bunch of that stuff, first of all, I know that at negative 3, comma 0 and at 3, comma 0, I have x-intercepts. And then at 0, comma negative 18 over 15, so just a little bit past negative 1, I have a y-intercept, so that's good. I have a vertical asymptote at 2.5. Maybe I'll do that with a different color here, so kind of coming down through here. Kind of gross, but picture that at 2.5, we have a vertical asymptote. I know that as I get towards the end, it's going to kind of level off like this. And I think that's our basic idea of what's going on here. So as we think about what the rest of the graph will look like, I'm just going to start on the left side. We know that from this arrow on the left side, it's got to get to this x-intercept. So I know it's probably going to go, oh, come on now. It's probably going to go something like this. And now what's it going to do here? Well, I know it has to connect with that y-intercept. And also, if I go back to some things we talked about with polynomials, the multiplicity for this x-intercept was 1. The x plus 3 part had a power of 1 in that numerator. And so that tells me it's going to have to go through there. It's going to have to go through, come on, Ben, and connect with that, and then it's going to have to just keep going down right here. So I have it actually touching the vertical asymptote there. It shouldn't touch it, but it's going to keep going down. There's no other place it can really go. Okay, it's not just going to run right into it and stop. And it can't go back up here because there's no x-intercept to the left of that vertical asymptote. So my only other option is to have it go down like that. Okay, for the right side, it's going to come through like this. And again, I have to think, what's it going to do at that x-intercept? More than likely, I could look at the multiplicity of that part of the x-intercept. X minus 3 had a power of 1. So that kind of tells me it's got to go through. Okay, and then just keep going down like the other side did. But if I needed to, now that's really close to 2.5, so it'd be kind of hard to test a point. But I could test a point a little bit and see, right in between 2.5 and 3, is it positive or negative? I think it would be negative based on what I'm seeing here. We could easily test that. But just based on multiplicity, I think it has to go through there. And then the other thing I just realized is there was a hole at 3. So I want to take away that filled in spot and put an open circle there to represent the hole. So that was a very quick run through of what we're going to do. And if you got stuck and had no idea what to graph, once you put in all these pieces, wherever you're a little stuck, just go ahead and say, well, maybe I wasn't sure what's going to happen at 2. Well, go back to your original function. Let's see if I can do that here a second. Okay, go back to your original function, either version, and plug a 2 in. So maybe I plug a 2 in here and here and here and here. Maybe that's going to be a little easier to simplify. So if I plugged a 2 in, I would get, I get a 5, and here I'd get a -1, and I still have that 2 in front. If I plug a 2 in the bottom, I would get a -1 and a -1, which is kind of convenient. So in the end, it looks like I should get an answer at when x equals 2, it looks like y should equal -10 if I'm reading this correct. So again, if I go back to my picture now, at 2, I'm definitely negative. Now, I'm not trying to make it super exact here, but that does tell me that it was negative and that I should graph something down that way. So I could do the same thing between 2.5 and 3 if I was kind of stuck on there, but that gets a little bit complicated. So that just gives you the general idea. Jot down any questions, and we'll see you tomorrow.